Okay, my name is the Civil Geek. I'm going to be showing you how to design a beam using Staady Pro V8i. Okay, let's start with the load. When we are doing the load, we want to calculate, we use the BS6399. We find out what is the density of a brick wall. For density of brick wall, it's 22 kilonewtons per cubic meter. Then the wall thickness, which is T here, and then the height. Okay, roughly above the lintel to the roof, we have a height of it's usually 700 millimeters. 700 millimeters. Okay, so when we have such, then we do a calculation of what is the UDL. Then the UDL becomes 3.5, let's just say 3.6 kilonewtons per meter. If you're going to design a 6-meter beam, you just replace that with 6. Our section size will be about 0.5 meters according to this. I will keep it in meters. I could use millimeters, but let me keep it in meters because the software that I'm going to be using is going to take all entries in meters. Okay, now when it comes to this, when you press new here, you are greeted with this screen, new model. Then you click space, then this is where you enter the name. Let me just name it Q. Then we are going to be using meters and kilonewtons. Then you click next. Here you say add beams, finish. Once you are done adding your beams, this is where you enter the information, the engineer that did it, the one that checked it, and the one that approved it. Okay, so as I said, it's going to be a 6-meter beam. I'm going to be using a snap node beam. So I'll snap at beam at 0, then at 6 meters, then I'll close. Here we have a beam that is 6 meters long. Right, once we are done with that, we go for the general. You click here when it says general, then we are going to define the section. When we are defining the section, we are going to define the size of the section. As I said, it's going to be a rectangular one. Then this is going to be 0.5 from our previous calculation, preliminary sizing 0.5, which is the same 0.5 that I use here. Walls are usually let me go here. The wall is usually 230 millimeters, so I'm going to leave it as 230. I'm going to add this one. Then I'm going to select this one. I'm going to assign it to view so that it will affect this thing. You see, it reads R1, which means reference 1, which is this one. Okay, if you want to see a 3D rendering, you can see now it's now a section. It's no longer a stick frame. Okay, once you've done that, you go to the supports, you create your own support. I'm going to be using pin support. I'm going to add that one. Pin support, I'm going to assign it to view so that it affects all the nodes. And say yes, you can see this now is a pin support. And I'm going to go for the loading. Under load case definition, I'm going to create a load case. Okay, once I've done that, I'm going to be adding dead load. So this is the dead load. I'm going to mark it DL for dead load. It's a primary. It's under primary. I'm going to add that one. I'm done. Under loads, under dead load, I'm going to add the dead loads. The dead loads are true. This first one is self weight, which is in the y direction, which means it's in the downward direction. It's -1. I'm going to add that one. Okay, this next one is going to be a member load. I'm going to use a UDL. As I have shown you in my calculations, I have a UDL of 3.5. Let's just say 3.6. Okay, so it's going to be minus, since it's going downward, 3.6 kilonewtons. It's going to be going in the global y. I'm going to edit. I'm going to close. I'm going to select this one. I'm going to assign it to view. Assign, yes. I'm going to be assigning this to view as well. Assign, yes. As you can see, it is shown up here. I'm going to select this load case. I'm going to add my load combinations, automatical load combinations. I'm going to be using the British standard, the one for concrete, which is BS8110. I'm going to generate that one. At when I'm done, I'm going to add. Once I'm done, these are now the load with the safety factor factored in. Okay. Once I'm done with that, I'm going to go to analysis. I'm going to select no print, add that one, and then close. Then I'm going to analyze this one. Save before analysis. Since, as you can see, there are no errors, so we are good to go. So once we are done with that, I'm going to go to post processing mode. Okay. Once I'm done with that one, I'm going to remove this unfactored one. I'm going to be left with the two load cases that are factored. Press OK. Right. Let me not look at deflection for this moment. Let me look at the moments. This is the moment. Okay. Then I'm going to go to results here. Then view values. Beam results. Then maximum bending moment. Annotate. Okay. Close. Okay, sorry. Maximum bending moment. Annotate. Then close. As you can see, it's going to be about 40 kilonewton meters. That is going to be the maximum moment at the center here. Okay, when we are done with that, I'm going to go back to the model. Now I'm going to do my design. I'm going to be using concrete here. You select concrete, then you go to CP 65, select that one. Then we select parameters. These are the parameters that I want to select. I'm going to deselect all of them for now. I'm going to be going for the clearance, which is going to be the concrete cover. I'm going to add that one. I'm going to be going for, this is the grade of concrete. It's FC in this case, but it's actually FCU if it was BS8110. Let me just select that one. I'm going to select the main reinforcement. I'm going to select that one. I'm not going to I could have selected this one, but I don't want to change it, so why would I bother myself anyway? Once I'm done with these selections, I'm going to define those parameters. The first one is the concrete cover. The minimum or the nominal cover is 0.025, which is 25 millimeters. I'm going to add that one. Then I'll go to the grade of concrete, which is 25. Let's use 25,000, so that it becomes kilonewtons per cubic per square meter. Okay, I'm going to add that one. Then this one, I'm going to change it to 460. You remember it's 460. Then because it's kilonewtons per square meter, you have to multiply it by 1,000. I'm going to add that one. Okay. Once I'm done, I'm going to go select this clearance. I'm going to assign it to view. Assign, yes. I'm going to go for the grade of concrete. I'm going to assign it to view. Assign, yes. I'm going to go for the steel. I'm going to assign it to view. Assign, yes. After I'm done with that, I'm going to go to commands. My commands, I'm just going to design my beam now. I'll select the beam. I'm going to edit. Right. I'm going to close. I'm going to select the beam. I'm going to assign it to view. Assign, yes, since we only have a beam. Okay. Once we are done with that, I'm going to go to analysis. Then select all here instead of no print. I'm going to select all. I'm going to add. I'm going to close. I'm going to go to analysis. Run analysis. Then I'll just wait. Okay, it's done. Now if we close this thing, then we double click on the beam, we'll find out this is the geometry, this is the depth of the beam, this is the section. It's telling us about the section, about the deflection. I'm only concentrated about this one. Okay, you'll find out that a beam that is 12 meters, that is 6 meters long, will only require 2 wide 12s. We did not take into account the roof, the load that is coming from the roof. but we are going to have two 12 millimeter, but two 12 millimeter beams. That is all that is required at the bottom, and links on the left and on the right. Okay, let me see. This is what you need. Okay, if you click this icon, is study output, select that one. This is where you have your results. Okay, this is the design. You are going to have a beam that is 6 meters long. You're going to use a FY of 460. This is the concrete. This is the size. The beam is going to be reinforced with the 2 white 12 bars. This is the calculation. I'll be giving you examples in future of real life applications. Let me just go through my drawings. I will find out which drawings that we can go through, then we will do the calculation together. Thank you for your time. Please subscribe, share, and like.